Write the expressions in simplified form. When we're trying to simplify our rational expressions, we want to make sure that the numerator and the denominator are broken into its most basic components in factored form. We're working with two quadratic expressions, and so we're going to use our patterns to help us put them into factored form. Now remember, your fail-proof way to factor your quadratics is your product sum method, where you take the leading coefficient times the constant and ask yourself, what times what gives you that product? So 1 times -6, what times what gives you -6? And adds to give you your linear term coefficient, -1. Again, for this one, we have to say what times what gives 16 and adds to get 8. We want to find numbers that will work for both the product and sum rule. And so we know we can use a -3 and 2 to make both rules work here. We can use a 4 and 4 to make both rules work here. Again, we want to be able to take those two numbers that we used and rewrite our polynomial, so now it has 4 terms as opposed to 3 terms. We want to write it as 4 terms because we can look at it in pairs and divide out what they have in common. So our polynomial here on the left, we can see the first pair has an x we can divide out. The second pair has a 2 we can divide out. Polynomial on the right, first pair we have an x we can divide out. Our second pair we can divide out a 4. When we do that, we can see that we would have a common term of x plus 2 being multiplied by x minus 3 on the left, and we had x plus 4 times x plus 4 with our polynomial on the right. Now that we have it in factored form, both polynomials in the numerator and denominator, we're going to rewrite our polynomial. So here we have our polynomial in factored form. Again, to simplify the rational expression, we're going to look to see if there's any like terms or like factors in the numerator and denominator that we can divide out. And again, those factors have to be an exact match. As we look and compare our factors in the numerator, we see that there are no matches in the denominator, and vice versa. As we look at our factors in the denominator, there are no exact matches in the numerator. However, we do see that it's the same factor in the denominator written twice. So if we want to write it in truly simplified form, instead of writing it twice, we'll write it to the second power. So here's our simplified rational expression, our quantity x minus 3 times x plus 2 divided by the quantity x plus 4 squared. We've been working with simplifying rational expressions through multiplication and division, and now we want to try the other operations, addition and subtraction. So let's try to tie it to some previous knowledge that we have. In the past, we've been working on adding fractions, like 2/5 plus 9/20. We have to remember that when we add fractions, we have to have a common denominator. So that means the bottoms of the fractions have to be the same. So we want to think about, well, what represents the denominator? What factors do we have? And so when we think about, well, 5, that's a 1 times 5, and 20, that can come from 4 times 5. So they've got this common factor of 5, and the only thing that's not the same match would be the 4. So since 5 is part of the 20, if my denominator was 20, I could add my fractions together. So if I'm going to say my common denominator is going to be 20, I have to figure out, well, what would I have to multiply this fraction by that's not going to change the value of it, just the form that it's written in, so the denominator would be 20. Well, we know 5 times 4 is 20. So in order not to change the value of the fraction, we're going to multiply the numerator and denominator of that first fraction by 4. So again, think about the value. 4 divided by 4, that's 1. So we're not changing the value of this fraction, just how it's written. So to get the common denominator 20, we're going to multiply 4 by the numerator and denominator of that first fraction. Again, when you multiply fractions, you multiply across. And so now we have got 8/20ths, and the other fraction, 9/20ths. Since the denominators are the same, we can add the like terms together in our numerators. So 8 plus 9, that would be 17. Again, whenever you have your fractions, look to see, do they have anything in common that you can divide out from the numerator and the denominator to put it in its lowest term, most simplified form. And here, 17/20, there are no common factors other than 1, so that would be our simplified form. So again, let's simplify our expression. 4/5 minus 1/3. Just like we did with addition, subtraction also needs a common denominator. So again, we want to think about the factors of those denominator values to help us get the common denominator. Well, we know 5 comes from 1 times 5, and 3 comes from 1 times 3. So they both have the 1 in common, and they both need a 5 and a 3 to be in common. Well, 5 times 3, that would be 15. So my common denominator would be 15. Again, we have to multiply each fraction by a value that's not going to change the value of the original expression, just the form, so we have that common denominator 15. Well, here, the first one, we were missing the element of 3, so I'd multiply the numerator and denominator by 3. Our second fraction, we were missing that element of 5, so we'll multiply the numerator and denominator by 5. So again, when you multiply your fractions, you multiply across numerators and denominators. In doing so, we will now have 12/15 minus 5/15. The denominators are the same, so we can simplify our numerators and combine our like terms. 12 minus 5, that's 7. Again, to make sure it's in its final format, you want to see, can you divide any like terms from your numerator and your denominator? In this case, we can't, so our final answer would be 7/15. So again, we want to write the expression in simplified form. 1/2 plus 7/4 minus 5/6. Like we did before, we want to think about what elements are in our denominator. So we have a 2 that comes from 1 times 2, a 4 that can come from 2 times 2, or 1 times 4, a 6 that comes from 2 times 3, and seeing if there's anything in common that we could have. Well, looking at the numbers 2, 4, and 6, I know that they have a multiple in common. 2 and 6 and 4 all have the multiple of 12 in common. So if I can make the denominators equal to 12, that would be alike, and then I can perform the operations. So if my common denominator is going to be 12, we have to think, well, what would I multiply each of my terms by to get 12 in the denominator? Well, 12 divided by 2 would be 6, so I would multiply both the numerator and denominator by 6. 12 divided by 4 is 3, so I would multiply the numerator and denominator by 3. 12 divided by 6 is 2, so I'd multiply the numerator and denominator by 2. So again, when you're multiplying your fractions, you multiply across numerators and denominators. So our first one, we would have 6/12, 21/12, 10/12. Since the denominators are like, we can perform the operations, so we can add and then subtract. So 6 plus 21 minus 10, that would be 17/12. Again, at this point, you want to say, is this my most simplified format? Do 17 and 12 have any common factors we can divide out? In this case, they do not, so it would be my simplified form. Now that we've reviewed adding and subtracting fractions, we know fractions are another way of writing rational expressions, polynomials in the numerator and denominator. we can use those same concepts and put them to use here with our rational expressions, adding and subtracting them. Typically, when you're adding and subtracting your rational functions, it's about 4 steps. First of all, you always want to find the lowest common denominator. If you find the factors of the numerator and the denominator, that would be helpful. That way, if you're finding the factors of both, if you do have any like terms, you could divide them out to start and then determine what elements you need for the denominator to be common. Once you figure that part out, you can multiply each expression by those factors in order to obtain the common denominator. Then you can add or subtract the expressions as directed. As always, you need to write your results in simplified format. So at the very end, if there are any like terms or common factors that you can divide out, do so. So let's take a look at a couple of these together before you practice on your own. Here we have our rational expression. Again, the first thing that we want to look for is writing the numerator and denominator in factored form. As we look at our expression, we can see the numerators here are already in factored form, the same with the denominators. The next step is to figure out what would be the lowest common denominator. So as I see, I've got 3 times k here and 2 times k squared here. Both denominators already have a k, but there are 2 present in this one, so I would need 2 present in this one. So k squared would have to be in my common denominator. I also need the elements of 3 and 2. Well, 3 times 2, that's a common multiple of 6. So if my common denominator had a 6k squared, I would be able to add those 2 expressions together. So again, we're going to multiply by what's missing for each term. So in order to make this a 6k squared, I would have to multiply both numerator and denominator by 2k. In order to make this a 6k squared, I would have to multiply the numerator and denominator by 3. Multiply your fractions like you normally do, numerators and then denominators. Now we have the common denominator, so we can perform the operation. 6k plus 21k. That would be 27k divided by k to the second. Again, we want to write this in its simplified format, so you want to look to see, does it have any like terms that you can divide out from the numerator and denominator? And I do see that we have k's that we can divide out. We're also working with our values of 27 and 6. Well, 27 and 6 have a common factor of 3 that we can divide out. So if we divide out a 3k from the numerator and denominator, we would be left with 9 divided by 2k. This is our simplified rational expression. So here we want to add our rational expressions. And the same rules apply as before. Are the numerators and denominators written in factored form? If not, put them in factored form. As of right now, everything is in factored form. Now we have to decide what would be the lowest common denominator. One fraction has our factor of x plus 2. The other one has a factor of x minus 4. Our common denominator would have to have both of those elements present. So our lowest common denominator would be x plus 2 times x minus 4. Now we have to multiply by the element that's missing in each expression fraction. So here I already have the x plus 2, I'm missing the x minus 4. So I'm going to multiply the numerator and denominator by x minus 4. This piece is missing the x plus 2, so I'm going to multiply the numerator and denominator by x plus 2. As always, when you're multiplying your fractions, you multiply across numerators, denominators. Which brings us here. So we have our common denominator. Now we have to say, what are we working with in our numerators so we can add them together? We can't add them the way that they're written right now in factored form. So we're going to write the numerator in standard form and see if there's any like terms that we can combine to help put this in simplified format. So that means I'm going to have to do some distributing. I'm going to have to multiply our two factors here and our two factors here. So as we get ready to do that, that will bring us to this step. 3x minus 12 plus x squared plus 2x plus x plus 2. As you can see, we have three linear terms we can put together and two constant terms we can put together. So in our numerator, we're working with x squared plus 6x minus 10 over our denominator of x plus 2 times x minus 4. We're working with a quadratic polynomial. As always, you want to see, can you put it into factored form to simplify it even more? So, quadratics, again, leading coefficient times the constant. What times what gives you negative 10? What plus what gives you 6? If you can find factors that meet both rules, we can put this in factored form and see, can we divide out any like terms in our numerator and denominator to simplify our expression? If not, it's simplified the way that it is. Well, my options for 10 are using a 2 and 5, and if it's got to be negative, one of them has to be negative. That will not give me a sum of 6. Another possibility for multiplying to get 10 would be 1 and 10. Again, I can't use a 1 and a 10, either one of them being negative, and end up with a 6. So our final simplified form is x squared plus 6x minus 10 divided by x plus 2 times x minus 4. Again, we want to write the expression in simplified form. Step 1 is the numerator and denominator of each expression written in factored form. As we look, the left fraction is already in factored form. The right fraction, the denominator, needs to be put into factored form. If we factor our denominator of a squared minus 49, we think about what times what gives us negative 49 and what plus what equals 0. And we remember a 7 and negative 7 will do that. This is also a difference of squares, a special type of quadratic pattern. So we know the two factors should be a plus 7 times a minus 7. Or if you want to continue with the product sum method, writing it as your four terms, factoring it by groups of pairs, so you'll still get the same result. So now we have the numerators and denominators in factored form. At this point, we have to figure out what's the lowest common denominator. So we look at our denominator. Here we have an a plus 7. Here we also have an a plus 7, so we have a match. However, we have an a minus 7 here that's missing in this fraction. So we're going to multiply this fraction, numerator and denominator, by a minus 7. Our common denominator would have to have both of those terms. So again, multiply across with your fractions. We've got the common denominator, so we just have to perform the operations. We have to distribute first to see what we're working with. So remember, we're going to multiply here by 4a. We also have to take the opposite of what we're working with. So that's like distributing a negative 1 here. So by performing the operations, our numerator now has 4a squared minus 28a minus a minus 1. Combine your like terms. And again, since we have a quadratic polynomial can you put it in factored form? So think about your product sum rule. What times what gives you negative 4? What plus what gives you negative 29? We know if we're multiplying together to get a negative 4, those factors will not allow us to add to get a negative 29. So this cannot be broken down any more than it already is. So our simplified form would be such. Write the expression in simplified form. In order to start, we have to make sure the numerators and denominators are in factored form. We see we have two quadratic polynomials in our denominator, so we want to put them into factored form if we can. So remember, we can think about our product sum method, what times what, and what plus what. Here, what times what gives us 2, but adds to get 3. What times what gives us negative 6, but adds to get negative 1. Thinking about the number patterns that we can use to satisfy those, we can fill in our options and then write our 4 terms to try factoring it by grouping. And we can see that b squared plus 3b plus 2 factors to b plus 1 times b plus 2, and 2b squared minus b minus 3 factors to b plus 1 times 2b minus 3. So again, let's write everything in with our original in factored form and think about what we need for the common denominator. As of right now, in our denominator, we can see that we have a b plus 1 in common. However, we're missing a b plus 2 in this denominator here, and we're missing a 2b minus 3 in this denominator here. So all three of those elements would have to be present to have a common denominator. So our common denominator would be b plus 1 times b plus 2 times 2b minus 3. So I go back to the original, and I figure out what's missing. Here I'm missing the 2b minus 3, so I multiply the numerator and denominator by that factor. Here I'm missing the b plus 2, so I'm going to multiply the numerator and denominator by that factor. Again, multiply across. We've got the common denominator, so we can write it as 1. We've got some simplifying to do, so we're going to distribute the b. We're going to distribute the 2b. Which brings us to here. Look to see if you have any like terms to combine. We've got some quadratic terms, some linear terms. So we've got 4b squared plus b. As always, can you factor the numerator? Does it have anything in common you can divide out? Can you use your, since the quadratic, your number pattern, what times what gives you 0 but adds to get 1? Well, here we can see both of them have a b in common, so I could divide out a b. And I would be left with 4b plus 1. So here's our most simplified version of our rational expression. We're trying to also see, are there any like terms that we can divide out to continue to simplify the process? And again, they have to be exact matches in the numerator and denominator. So I have to see something like a 2b minus 3 here as well in order to divide it out. So if I'm comparing my items in the numerator to the denominator, I do not have any exact matches for factors in both locations. So this is our final factored form or simplified rational expression. Now it's your turn to practice. You're going to continue on with your day 10 notes, working on your numbers 5 through 12, utilizing the concepts that we've worked on today. You also have a nice guide if you look at your day 10's kind of reminder, or day 11 reminder page, working you through a couple more examples about how you can add and subtract your rational expressions. And we'll check your results tomorrow.